Like said, my name's Elayne Juten. I work at cars.com. I'm a software engineer. And I wanted to give a talk about pattern matching. I started programming in Elixir a little over a year ago with cars. And coming from Ruby and the object-oriented programming world, pattern matching was a concept that I really struggled with. I understood the greater concept. We're taking a set of data to see if it matches another set of data. And if it does, great, we'll do something. And if it doesn't, great, we'll do something else. But continually in PR reviews and in pair programming, I would get continual feedback of, well, you can pattern match this and clean up a lot of this code, which is great. I love feedback, but also, what the hell? Why? Why is this wrong? I was very frustrated, and two main questions kept coming up for me. One was less what is pattern matching, but more what are the different tools that I can utilize in Elixir to pattern match effectively? And two, why? My tests are passing, my PR looks good, CI's green, so why would I choose it over my if-else blocks that I loved so dearly from Ruby? So that's what I want to explore today. I wanted to create this talk for folks that are newer to developing in Elixir. So one of the first things when I started an Elixir tutorial was this equal sign is a match operator and not an assignment operator like I knew it in Ruby. So we're checking for a match of data on either side. That makes sense as a match operator. But with an assignment operator, like in Ruby and object-oriented programming, when we declare a variable, we assign a value to that variable. But with the match operator, we bind that value to the variable. But we'll talk a little bit more about this later. But let's open up an IEX shell in a terminal to take a closer look at this match operator. So here I have a variable x, and it's being bound to the string cat. And when I hit enter, I get the string cat out. We've bound the variable successfully. Great. So now let's actually text this match operator. So here I have the string cat, and we're matching on the variable x, which we know is the string cat. So when I hit enter, I get cat back. We have a successful match. But we're not here for success. Let's see if we can break this thing. So here I have the string dog. I am matching on the variable x, which we know is string cat. And we get a match error. We love errors. This is great. We're good. So then it says no match of the right-hand side value of cat. Perfect. So now we know we get a match error when the values don't match. But let's try another data type. So here I have a tuple of OK and cat. Clearly, there's going to be a cat theme, so get ready. And I'm binding it, or I'm matching it to the variable of x. I want to try to trick the computer because I'm pretty smart. And so I put the string cat in here, being like, it's going to match because it sees the string cat. But it doesn't, so the computer wins again. No match on the right-hand side of the value, string cat. So we get a match error also with the data types being different, no matter if there is a matching string within that data type or not. So let's take a look at a couple more examples with some more complex data types. So we have lists and maps in Elixir, and lists are pretty strict when we use it within pattern matching. The list needs to match by the number of items and the order of those items or elements within that list. I have an asterisk there by the number of items. There is a workaround, but we'll see that later. It'll be a nice surprise. It's like a gift, but I don't have any items for anybody. All right, so let's take a look at an example in code. So here I have a variable list, and I'm binding it to a list of elements. We have Henry, Otto, and 13. Henry and Otto are my cat's names. And when we hit enter, we get that list back out. We've bound that variable successfully. So now I'm going to rearrange the original list of the elements. So now we have Otto, 13, and Henry, and we get a match error. So again, that list needs, the elements need to be in the same positions they were when you bound that list originally. So here, I'm going to add an additional string on the end of my list. I have penny, and I'm going to match it onto that original list value or variable. And again, I get a match error. So we get a match error when the lists are of different sizes as well, even though the first 3 elements are in the same order. So Elixir lists support matching on its own head and tail, which I find really cool. It's something that I didn't quite understand until I got this talk accepted, and I was like, guess I should really learn pattern matching. And I find it really fascinating, and I have used it since, so I'm doing really good. So here, if I print out each of these variables, so I'm assigning head and tail, there's that pipe symbol in the middle, and I'm assigning it to a list of Henry, Otto, and 13. So when I print out each of these variables that I set, head will print out Henry, which was the first element of our list, and tail prints out the remaining elements of the list in a list. This might be old news to folks, but it kind of blew my mind. And the cool thing too is you don't need to name the variables head and tail, and you can have multiple heads. What? So let's take a look at an example of that. We have a list set up here with 3 variables. We have cat, mouse, that pipe symbol, which indicates what are our heads and what's the tail of the list, and a variable dog. And I'm matching it or binding it to the strings within a list, Otto, Cheddar, Baxter, Rover. So when I print out cat, Otto, which is the first element of that list, gets printed out. When I print out mouse, the second head, Cheddar, gets printed out, which is like a great name for a mouse. And then when I print out dog, I get the remaining list that's available to me. So Baxter and Rover get print out. So this pipe symbol is used in pattern matching, but it can also be used to prepend items to a list as well. I just wanted to point this out. It's kind of cool as well. I have a cat list variable, and I'm binding it to a list of Otto, Henry, and Nix. We get Otto, Henry, and Nix out. The binding is successful. And then we can say the string penny, that pipe symbol, which is prepending, and we're adding it to that cat list variable that we set up. And when I hit enter, we get that prepended string in that list. So now we can move on to maps. Maps tend to be our go-to when we need a key value store. So it's one of our associative data structures that we have in Elixir. I like to think of it as kind of the Wild West of data types, because any value can be a key. There's no ordering. It's basically like, this is gonna date myself, but lists is like Ashley Olsen, and maps is like Mary-Kate Olsen. If you know, you know. Yes, okay, thank you. Yes, some people like it. All right. So here, I have a variable map. I'm binding it to a map, and we have 3 keys and 3 values. As you can see, the keys are different data types. The values are different data types. And then when I print out each of these keys, we get that it successfully created this map. And so now, maps will match on a subset of the given value. So we can add additional key values. We can remove key values. If the key in the pattern exists, we'll get a successful match. So here I'm saying, hey, if the key of A is in this map, we want a match. And we get a match because there is a key of A, and that's bound to the string of Henry as the value. But what if we change up the order? So like lists will yell at us, but here I'm putting penny in the middle, and I'm putting the integer of 2 at the end. So I'm switching those up. And, oh, okay, well, it's still gonna match. We're still gonna get a successful map put back out for us. So the only time we'll get a match error within maps is when the key is not in the map at all, which makes sense. So here we're checking to see if there's a key of C. Within this map, there's not, so then we get a match error. So let's review there's a myriad of ways we can get a match error. I probably have gotten them all. So we get a match error when the values don't match, when the data types don't match, when the data types are of different sizes, and this is like particular to lists, and when keys in a pattern don't exist, and this is, again, particular more towards maps. So I said I would come back to this. Here we go. This is the binding versus assigning with that match operator or that assignment operator. So this is kind of this is part of the, so Elixir has immutable data, and the binding is part of it. So when we're using that match operator, we're always doing a pattern match that either succeeds or fails. So binding and assignment deal with memory in a little different of a way, and there's a lot more nuance to than just these like 4 points, but essentially binding, the memory location moves around, but the value stays the same, and with assigning, the memory location stays the same, but the value moves around. I still don't fully understand it. It's a rabbit hole that I really want to dive into, but I need to finish this talk first. So after this talk, I will pull up Google and start learning a lot more about memory allocation. It's something that if this sounds interesting to you, definitely dive in. There's 500 more talks about this probably that could be made. It's really interesting, but that's for a different talk. So yeah. So hey, we're midway through this talk. So some takeaways that I hope you take away. Pattern matching can be used on simple or complex data types. Lists are strict in their ordering and their size. Maps don't follow any orders, Mary-Kate Olsen, and keys can be any value. And match errors occurs when the values or data types don't match. Data types are of different sizes with lists, or keys within the pattern don't exist. So, wow, cool. This is great. But how do we use these concepts on a larger scale? I have legacy code that this is great, but like I can't really use it. So let's take a look. So we have in Elixir a bunch of different pattern matching constructs. I'm going to talk through 3 specific ones today, but there are more than that. So we're going to cover multi-clause functions, we're going to cover case statements, and conditional statements. So multi-clause functions is first. So a single function can have multiple clauses. Next, just kidding. So it's a little different than function overloading, since functions in Elixir are identified by their arity or number of arguments. So let's take a look at some examples. So here we have a module of animal. Every animal has a sound function, and we're passing in a specific animal and returning a specific sound. So Elixir will go from top to bottom looking for a match, and if no match is found, we'll get a function clause error. So if I were to call the sound function and supply it with a string of dog, I'll get arf back out. And if I call the sound function with the string of bird, supplying that, we'll fall into that third function head and caw will come out, because that's what birds say. So multi-class functions I found are a really great way to help eliminate the control logic from functions. It streamlines code into simple bite-sized pieces, and it makes it easier for me to parse it when I'm writing new code. I find it a lot easier to be like, okay, we are looking at a dog here, so then it'll fall into a certain function and we can use that data to change it to be something else. But also, it's way easier for another dev to come in and remove a function head, add a function head, and there's kind of a pattern. Let's see what I did there. There's kind of already a pattern set up for them to use. But there's more animals than 3. So if we keep our code like this, we're asking for function clause error after function clause error. So that's when the underscore comes in. So the underscore is kind of like the default value. We use the underscore when we don't really care about the value that's coming in. So we want to use this with caution. We don't want to put this everywhere. Sometimes we actually want to see an error and know that there's more work to do. But for the sake of this exercise, I'm going to add the function, the default function under here. So if the animal is not a string of dog, cat, or bird, we're going to put back out to the user, hey, this isn't one of the animals that we have. So a nice accessory or condiment to the pattern matching hot dog are guards. So we have a module of cat, and then we have 2 multi-class functions of pet, where we supply the age of the cat, and then we use our guard of when the age is over 10. We want to remind the user to pet that cat gently. They're in their prime time of their life. So guards allow us to be a little bit more complex in our matching checks. So we have a predefined number of expressions that can be used to ensure nothing goes sideways while executing. So when in doubt, I usually pull up the documentation and look at what's available to me, or if I'm feeling wild, I'll pull up an IEX shell and test it out, and if it fails or I get errors, I know it's probably not a guard that I can use. So case statements are next. We compare one value against many different patterns to help find a match. So here I have a module of housing. I have a house or barn function, and then I'm casing over the animals. And then I'm looking at this. I have multiple lists. So I have a list of cat, dog, and mouse. We're going to output typically lives in a house. We have a list here of pig, goat, and then there's that pipe symbol again, and then that default thing again. This allows us to not care about anything past these 2 elements in a list. So this is where Ashley has a wild night out. So we want pig and goat to be within that list. It has to be in the pig and goat order, but after that, if it's a list of 40 elements, we don't care. If it's a list of 3 elements, we don't care. If it's just pig and goat, great, it's gonna pass. And that will output typically lives in a barn. And then we have our default function down below. Can't live in a house or barn, it's probably a bear. So if I'm just assuming. So if I call the housing module with the house or barn function, I supply pig, goat, and horse. You can see that we fall into that second case statement. Because we have pig and goat, we don't care that there's also a horse there. They'll all go in a barn. So we get that successful second case statement output. So if I didn't have that default value, and I supplied it, okay, so I'm supplying it the housing module with the house or barn function, supplying it a list of turkey, ferret, and flying squirrel. Those can't go anywhere. So then we get a case clause error. There's no case that's matching this string or this list that you expect. So that's when a default function is pretty nice to have within reason. So last but not least, and not the last concept that Elixir has with pattern matching, is conditional statements. So these are used when you want to check multiple conditions to run code for whichever one ends up being truthy. So here we have a conditional of the string cat is equaling the string dog, which that's false. 2 times 2 is greater than or equal to 6. That's also false, though my math's not very good, so it might be right. And then I have the tuples okcute equaling another tuple okcute. So that one's truthy. So then we fall into this third conditional. So it's going to go again from top to bottom and see whichever one ends up being truthy to get that output that we need. So if all conditions are evaluate to false or nil, we'll get a conditional clause error. So I've changed the okcute, then we don't want these tuples. They're not equal, they're different. So then, oh, fun. We get the conditional clause error, no conditional clause evaluated to a truthy value. So if we wanted to avoid this error, if like previous, like the case statement and the multi-clause function were to kind of create this pattern, we would put an underscore here. But since we're looking for truthy, falsy, or nil, we want to put a true as our default value within conditional statements. I always forget this, and then it always yells at me. And then I'm like, oh, okay, yeah, I need true. So I put a true conditional in here. This will always work. If everything else is false, we'll fall into this default condition. And my poorly set up slides will say this will always work. So we do get into that default. So a little bit of review. We have multi-clause functions, a single function that can have multiple clauses, executing from top to bottom. So we want our more complicated matches up at the top and then trickle down to our more general and default cases. Then we have the case statements where we're comparing one value against many different patterns. The conditional statements where we're checking against conditions and run whichever one is truthy, and we're only checking for truthy, falsy, or nil. And then we have our little condiments. We have our guards that allow us to be a little bit more complex within our pattern matching checks. And then we have our underscore. We don't care about this value. It can be our default. So these are great tools, use them all the time, but then how do we use that within legacy code that we want to refactor? So let's take a look at some examples. Gross, you can't see that at all. I'll zoom in, I promise. So this takes up the whole page, and it's a pretty simple example. So let me zoom in. There we go, that's a little better. So we have an animal module with a sound function that's being supplied an animal. And then if the animal type is a certain thing, and if the age is a certain thing, we'll supply a sound. So let's refactor this. My first thought is I'm going to keep matching on animal type. That seems cool. So let me use a case statement. So here we go. Oh, okay. Oh, gross. Still pretty long. That's a lot of code still. It's still large. It can become unwieldy pretty quickly. We still have some nested if-else blocks, and that's just like, that's hard as a dev that's coming in to refactor code. It's kind of hard to get different functionality within there if you want to add something. And I could still see some additional refactoring. I maybe could have done this the first pass, but I was lazy and wanted to get this PR up by 5. So I could remove that aardvark else case altogether because we have that default here at the bottom. But I don't really want to continue down this road, so let's try using multi-class functions. So I'm going to start out with the cat. Since it is the more complex, we have the if-else statement within the original pre-refactored. So this is the most complicated, so I'm going to start and put it right at the top. So I have a sound function. We want some sort of struct with a type of cat and an age. And then I'm going to use my guard when that age is over or equal to 10. We want it to output a specific sound. So next, that was pretty easy. Let's move on to dog. We still have an if for a dog. So again, I add a sound function with a struct. We want it the type of dog. We want the age. And when it's over or equal to 10, we want bark to be returned. And so then we can focus on our last, more complicated setup of aardvark. So here, again, any kind of struct, type of aardvark. When the age is over or equal to 3, I'm assuming an aardvark squeaks. I should have Googled that before I put this in the slide. But now we have all of our general cases. So this is going to go quick, pretty easy. We add our struct for bird. We add our function, sound function for cat of that, like that else of the original code. We add cow. We add dog. And then we have this default function here. So as you can see, this code is pretty clean. It's pretty easy to understand where it's going to fall, what's going to be returned from it. So say we want to get meow to be output. I can call animal.sound, supply it an animal struct with the type of cat, the age of 13, and we get meow returned. But that default thing where I'm always like, be careful with it, I think we can make it more strict. But let's see if we need to. Let's test this out. So we expect this function to supply a struct. Great, but what if it doesn't? So I'm going to call animal.sound with the integer of 13. And we still get that default, which might be okay, but I think if people are supplying integers and nothing but integers, we probably want to know about that. We either want to have a calm talk with the user and tell them why are they searching integers when they should be searching animals, or it could be a different function we want to add all together, and we would never know about it when it's just falling into this default. So here, I'm adding a struct with a type. We know we want a type, but we don't really care what that type is. So now, I'm going to call animal.sound with the integer of 13, and we get a function clause error and a good error. This is the error we want. We want to make sure that we're instructing the users to input the correct things, and then we're also seeing if there's a ton of errors, maybe there's a function we can add, or a feature we can add. So I'm going to make it more strict. So previously, we had just any struct. That's great. We'll take it. But there could be a different struct that isn't just animal, that has a type of a string of dog or an age. There could be a second one. So I want to make it more strict. So instead of this any type of struct, we're going to make it an animal struct. And I think that looks pretty good. There might be ways that we can refactor more, but you know, it's 5:15. I want to go home for the day. But let's take a look at another example. This one's a little more chaotic. So you would git blame that right away. Find out who did that and tell them good job. But don't git blame this because it was me. So again, this is still a fairly small function example. So we're taking a look, if we zoom in to make this easier to read and take a look at our if cases, we have a feed function and that we're looking at the cat's age, the cat's weight, and the cat's appetite to print out an amount and certain type of food that that cat can eat. So it seems like a great case to break apart this work into separate functions. Since we're doing 3 different checks and 3 different processes, So first, let's strip this back. We have the cat module, we have a struct, and then we have our feed function that I'm kind of going to use as the executor to make sure everything runs. So we have that set up. So the two main questions that we have now are what are the type of food and how much food do we feed these cats? So let's go with the type of food first, since it looked like age was the only thing that is determining that. So here I've created a private function of type of food. We're supplying it a cat struct with an age, and I'm doing a conditional here. So if the cat age is over or equal to 10, we're gonna output wet food. And then since my struct is so strict here, I feel comfortable putting that default value of true. So I actually recently had a conversation with a coworker that made me question everything, where we were talking about this would be a good case for an if-else. Gross. But it's appropriate if we're just checking true and false. If it's if this is true, great. Else, we're going to do something else, like else's are. This might be a good case. If we add a third type of food, maybe raw food, then that brings back the case for a conditional might be a nice thing to check because we're checking on multiple cases. But if it's just two, if else might work. But for the sake of my mental sanity, I was like, I'm keeping this. I want to show that a conditional can work here as well. I think it's just personal preference, dev preference. But I found that really interesting, but didn't want to do the extra work to change this back. So we have our conditional, we have our type of food. So let's move on to the amount of food. So here I have a case statement. So I have an amount of food private function. We're grabbing the weight and appetite, and I'm putting it into a tuple just to make it easier to match within that case statement. So if the weight is lean, but the appetite is strong, we're giving them 30 ounces of food. I'm not a vet. Talk to your vet. This is not scientific data, though my cats probably wish it were. If they're lean and moderate, 25 ounces, and so on. So the case statement will look through all of these. If they match, we'll get an amount of food output. So here's what we have so far. I know it's a little hard to read. It's probably smaller font. But we have our type of food and amount of food private functions here. And so now we can add those into our feed function to get this working. So here I have a food type variable and a food amount of variable. And I'm assigning, or binding, my Ruby showed, I'm binding them to the type of food and amount of food functions, and then I'm interpolating that back out to the user. We could just call the functions right in that interpolated string. That makes my eyes bleed, so we're just gonna put it in variables. But again, personal preference, that might be feedback on a PR review. And here's what we have. It's a lot shorter. It's still not great for the slide, but we can test this out. So I'm going to call cat.feed. I'm going to supply it at an age of 13, weight of normal, and appetite of strong. So if we follow along, we should get 25 ounces of wet food back out. And we do, which is great. But let's take a look at that feed function again. So I think we can do some cleaning up. This is a really good refactor. I would commit this. But I think we can refactor some more. So we're not actually using the elements of the cat struct in our feed function. It's just simply there to then pass on to our private functions. So I think we can add an underscore to indicate that. So I'm adding an underscore to our age, weight, and appetite variable. We don't really care what that variable is in the end because it's just going to get passed on to our two other functions. And now let's go crazy. So we can bind this struct to another variable. So I am binding that cat struct to a variable of cat. I love cats. And now we can clean up our private function code. So here, I'm taking away the structs that I supplied originally, and I'm just passing that cat variable. So we still have the strictness of our struct, but it's a lot cleaner. And then in the larger code module, we can see that it kind of cleans up that function call, that function head. Okay, we know it's getting cat. What is cat? We look up at our executor and see that, oh, it's the cat struct. Great. So just a reminder, this is where we started. That's, I can't believe I wrote that. That's fun. So there's a lot of if-else blocks here for a pretty simple functioning code base. But more importantly, I think there's a lot of different processes that are happening within one function. And typically with those if-else blocks, it's really hard to go in and add something new, because you're going to have to rearrange everything else. It's hard to pull it back out, because then there's that indenting problem that is really annoying. And so what we have now is both easier to read personally, and I think it also is kinder to the devs of the future that come in to see your code, because they can refactor pretty easily. Maybe there's a different weight and appetite. Maybe there are different animals. There's ways to refactor this out into more complex functionality, and you can do that easier with pattern matching. So that's it. Wow, that's a lot of information. I'm excited to get some ice cream later. But let's talk through some of what we learned today. So pattern matching, we're checking if both sides of the match operator match. We have our multi-clause functions, our case statements and conditional statements that help us to create more streamlined and easier to read code bases with our accessories or our condiments of guards, underscore variables or the pipe symbols. And then we can get match errors when the values or data types don't match. Data types are different sizes. Keys within the pattern don't exist. The match error will kind of help guide you to a successful match. And if you see a bunch of nested if-else, it's a cry for help, but also it should have a big sign that says refactor me. It's really fun, I never thought I'd say that, to go in and clean it up and make it look sparkly new, make it look easier to follow, and future devs will thank you, as well as yourself if you have to go back into that code base. And that's it. So thank you so much.
Thank you so much, Elayne, for that masterclass on pattern matching. That was so cool. Any questions from folks in the room? I've got a question. What was challenging about learning about pattern matching? What did you feel like was hard to grok, and when did it start to click for you?
Yeah, I think all the different constructs that were available to me, I kind of just, when I first learned it, I was like, oh yeah, equal sign, whatever. And then when I was digging in, there was so many different ways to go about it, and which way was the best way, and it took me a while to let go of the if-elses. And it could have been just, I'm still junior, I'm like 4 years into programming. And so—
Not junior, give yourself some credit. 4 years. 4 years is a long time, give yourself some credit.
I don't know. I still, cool. Yes, I am enough. But, yeah. But I feel like I had solid knowledge of that, so kind of breaking that apart into different ideas was cool, but also terrifying. And it took me a while to kind of figure out, And I'm still working on figuring out, like with that first example, like, oh, I use case statements, and it doesn't work as well as it could. So yeah, just kind of keeping more of an open mind on that was hard.
Thank you.
Yeah.
Any other questions? Yeah, Adolfo.
Well, congrats on your talk. I'm going to use it with my students next week because it's a very interesting way to show pattern matching. And I like to see that you used Lucas Veggi and Marco Tullio's Valente work on Elixir code smells. And
Yes.
my question is, during your talk, you showed the wrong way and then the right way. I'm not sure. Do you think this is good for beginners, or it's because here you know that most people already know Elixir, and then you did that to highlight how good pattern matching is?
Yeah, that's a good question. I wanted to gear this talk towards beginners, and to be clear, I don't think the nested if-else are technically wrong. Like, they're passing. I made sure that it passed in IEX, and like it was doing what needed to be done. But I really struggled personally when I was learning Elixir to take those if-else blocks and think about what else I could do to maybe clean up that code. So that was my approach to this talk. And it would, if I got this talk accepted, it would force me to like really learn pattern matching. So that was a really nice bonus. But yeah, I think it could be because I have some previous Ruby knowledge. Maybe it is a little bit more advanced than I thought it was. But yeah, that's a good point. That's a really good comment.
I really don't know the answer, if it's good or it's bad. It's only
I tried to make it as beginner as possible. But there is like some knowledge of Elixir, like if you're just starting out, like starting in a tutorial, I think would be helpful.
Yes, it's a point I have to make is that usually I open my course and I invite people with no programming experience, but it never happened. It's always someone with some previous experience, so maybe your examples are very good for them.
Yeah. I mean, personally, I don't think I would ever have done programming if I wasn't in a lot of student loan debt, and my opera career was not happening. So it was something that I originally financially chose to do, and then I ended up really liking it. So,
okay. Thank you very much.
Yeah.
Any other questions, opera related or otherwise?
Have you found pattern matching to be the hardest part to learn in Elixir, or maybe equal with other things, or do you think there are other things that are harder?
Ooh, I'm still learning Elixir. I think pattern matching was my personal biggest hurdle, because a lot of other things tied into Ruby knowledge that I kind of already had. So it was like a little different. It was a great, the previous talk had talked about like Romance languages, like you're switching between Italian and Spanish. And that's what I felt when I started in on Elixir after going to Ruby. But then there's a certain point where it drops off and you know nothing again. And I feel like, I think there is definitely harder stuff in Elixir, but I think getting past this first hurdle gave me that little bit of confidence that made the other stuff not as bad, where I'm like, well, I can pattern match, so everything else is fine. And it also gave me the kind of the habit of going to the documentation, because the documentation is so good, as it's been stated many times. It's been really nice to kind of build that habit in for myself, so then the next time I'm approached with a problem that I'm like, oh, I don't really know, the hex docs are like the first thing I go to.
Cool, thank you.
Yeah, thank you.